Okay, this is the moment you have all been waiting for, the coding problem. First, let's start with a simple code problem. So we have the state class, which is basically an interface. The methods will be kind of overridden like later in the concrete state classes. Draft is a state, moderation is a state, published and archived. However, as you see, so not all of the states implement all the methods in the interface. So if it's the draft state, then just the submit method will be implemented. The document class, which is basically the context, an object of it will be created, and this object is called doc. So doc we would call the submit method, and then approve, and then archive, and then restore. What is happening is that we need to manage the states of a document in a content management system. The state design pattern here kind of allows us to encapsulate the behavior associated with each state into the separate classes. Let's say the draft state. Of course, you could see the modularity and the maintainability and the scalability out of this pattern. And as you see, each state is kind of managing its own behavior and transitions. And overall, it reduces the complexity in the main document class. First, as I said, the doc object is being created, an instance of the context class, which is the document. Then the submit method is being called. Let's see what happens when the submit method is being called. Well, the state variable of this very class in the constructor is an instance of the draft state, and then it makes sense when the submit method of that state class is being called. So let's go to the draft class. Draft class, of course, implementing the submit method. It will need the document object, and it's getting it. It will print submitting document for moderation, and then it will change the state to moderation. Then approve on the state which is now moderation. It will call the approve method, and then it will change the state to published. The same pattern is happening with archive and restore. Archive will again go to context, then go to the published state class. Later, state will be changed to archived, and once we go to the restore method, it will go again to document, now to archive the state. Another state will check to the draft state. What if we run this program? Yes, all those print statements that we were expecting. First, take a look at the UML just to visualize everything. Traffic light is the context. Then we will have the state interface and a lot of concrete states, specifically 5 concrete states. Again, a traffic light could have different states. It could be red, yellow, green, or blinking yellow light as at nights, or it could be in maintenance state. And each of these states could have different behavior, specifically the transition. So let's say if it's red. After red, we expect green, but once it becomes green, then the transition would be to yellow. Now I try to do an overview of what's kind of happening, starting with traffic light class. So, for an instance of this traffic light, we will of course need to give it the duration of the red light, the yellow light, and also other states to begin with. We will start with red state. We will take into consideration the different events that can happen. Let's say let's say an emergency vehicle passing, once the traffic density might change, weather condition, and also we will take into consideration the historical data. The change method, probably the most important method to begin with. This is the method we will start with in the test lines of codes. Could be misleading because you might think that change is happening here, but change is happening in the on these lines of the state dot handle. Once it will go to, let's say, red state, the actual transition to green light is happening there. You could say that indirectly it's happening here. We will log the states and things that happen. We will write them into a file. We will use probabilities in order to consider some chance, whether it is emergency vehicle or once we have to go to manual override. If this code is run between 5 a.m. and 6 a.m., it will be just blinking yellow light. Based on traffic density, the durations will change. If there's a failure, we will go to maintenance state. We will update both density, traffic density, and also the weather condition. It will affect the durations of the lights. And we collect historical data. Later, we will analyze them in order to change the durations in real time. The state interface, just a handle function. Then let's say the red state, we will say red light, stop, and the logging, the waiting, and the changing to the next state, which is in this case green. Similarity for yellow state, similarity for green state. Blinking yellow and maintenance state are sort of different. So you can see, for example, in maintenance state, we will terminate the program. So the thing is, these are the specific behaviors that we can implement once we are benefiting from this state, from this design pattern. Imagine all those conditionals. Now it's just a state design pattern. For testing, we will create a traffic light instance and we will start calling methods. The interesting part is we don't know what will happen. We will let the program go for some time and then we will analyze what has happened. Obviously, just for some time. At this line, traffic light dot change. Then it will go here. We'll call this method and some checking. And then state handle state is we're starting with red state, so we come here, red light stop, and that's what's happening here. And then yes, the logging state already changes, but coming back, let's see, we're detecting a vehicle. So yeah, based on the chance, so it seems that uh vehicle has been detected. Let's go to find the code. Okay, yes, 50% chance, and we have extended the green light based on that. Then moving forward, it seems that pedestrian has not pressed the button, public transport hasn't been there, but emergency vehicle chance has been like the emergency vehicle variable has been set to true. That's why we're getting emergency vehicle detected, and we're turning green in that situation. This update on traffic density happens all times. It's on a scale from 1 to 10. Uh, People are so unlucky this time. Of course, with each update of traffic density, there will be adjust on light durations. Also, it's the same for weather conditions. Has come back to the loop again, change, uh, but at that time it's green state, so we'll come here. It will change the state to yellow. It will continue to check for the multiple situations that can happen. uh, this is really like, you could kind of see the benefit of state design pattern when you see that state changing is just happening. Vehicle, again, vehicle has been detected. This time nothing has happened. The chances are too low. No emergency vehicle, no public transport. Then so we come down to the updates. The yellow light, again the same thing. It has gone to the change um, method, and then the yellow state, and this pattern continues. I think the golden part of this is all those um, durations for red light and green light that change based on different things that can happen. It's interesting. At some point, the red and green light are like 15 and 15, but then they change. And this is due to a lot of different factors. It kind of shows how complicated the traffic light system could be. So if this code is run between 5 a.m. and 6 a.m., there will be blinking yellow light. If somehow there will be a traffic light failure, then we will go to maintenance state. Okay, thank you so much. I hope state pattern will be one of the patterns of your programming, if not one of the patterns of your life. Thank you.